Welcome back to another week of geometry. Today we're going to finish up our work with probability to be able to discuss how to appropriately choose whether or not a given probability will work or how we can determine the chance of something occurring. So what we're going to do is we're going to look at this warm-up problem with Sally, whose mother has 2 bags of candy, which says that Sally can only have one piece. Bag 1 has a 70% orange candies and 30% red, and bag number 2 has 10% orange candies and 50% white candies and 40% green candies. So Sally's eyes are covered and she chooses one bag and pulls out the candy. What's the probability that she chooses an orange candy? Now, in order to kind of bring our mind back into what we were talking about, what we're going to do is we're going to create an area model. And as a reminder, an area model is taking a generic rectangle, something that looks like this, and we're putting our two options of, I'm going to put bag number 1 over here, and I'm going to put bag number 2 up here, and we're going to list out the associated probabilities with each of them. So bag number 1 has a 70% chance of getting an orange candy. Now I don't need to draw this equally, but 70% is the same thing as 0.70, and so this is an orange candy. So the probability of getting an orange candy is 70% or 0.70. And then the probability of getting a red candy was 30%. So down here, this whole row represents 30% or getting a red candy. So I'm going to label that as such. So going straight across 70% and 30%. However, bag number 2 has 3 different options. And so what I'm going to do is I'm going to partition the top into 3 separate categories. It says that bag number 2 has 10% orange, and 10% is written as 0.10. So that's orange. Excuse me, I need to write correctly. Additionally, it says it has 40% green candies, and 40% is 0.40. So that's green. And then lastly, it says that I skipped over one, but it doesn't matter the order I write those in. 50% white candies. So 0.50, and that would be white. Okay? So Sally's eyes are covered and she chooses one bag and pulls out one candy. What's the probability she chooses an orange candy? Well, as we go down the possibilities of what she could draw, here could be orange and orange. Here could be orange and green. Here could be orange and white. Here could be orange and then red. Here could be green and red. And here could be white and red. Those are the possibilities from grabbing those. So what I need to do now is I need to calculate the probability of this taking place. So for her to get orange, that would be multiplying together the 0.7 and the 0.1, the two associated probabilities with one another. And in doing so, 0.7 times 0.1 is equal to 0.07 or 7%. And I'm going to continue down calculating all of the associated probabilities for each of these different scenarios. Alright, so what I did is I multiplied together the area of each of the smaller rectangles, which represents the probability of that event occurring. And so you can see the associated probabilities written as a decimal and as a percent in each box. And then to answer the question, what's the probability she gets an orange candy? Well, I circled in red all of the different scenarios where she would get an orange candy, and then I added up those probabilities down here together. So 7 plus 28 plus 35 plus 3% all add up to be 73%. So she has a 73% chance that she's going to end up picking an orange candy. And so this was constructed using an area model. And so today we're going to expand upon that a little bit further, but I'm going to show you another method that we can also use to help us determine the probability of a given event. So we're going to go into problem 464 in lesson 4.2.2. It says using a tree diagram. In the previous lesson we used an area model to represent probability situations. Today we're going to consider how to represent those using what are called tree diagrams. So the basis for this problem says your teacher challenges you to a spinner game. You spin the 2 spinners with the probabilities listed at the right. You can see the 2 different sets of probabilities from spinner 1 and spinner 2. with the associated letters there. If the letters can form a two-letter English word, you win. Otherwise, the teacher wins. So, for example, if you got I and then T, that's it. That's a word. So you would win in that instance. It says, are the outcomes for spinner 1 and spinner 2 independent of one another? Yes, these are independent, meaning whatever I get on spinner 1 is not affecting what is taking place on spinner number 2. So that's important to understand, that they are independent of one another. And then part B says, make a probability area model of the sample space. This is just like what we did in the warm-up problem. So what I'm going to do is I'm going to create an area model, and I would encourage you really quick to do that as well if you have not done so already. Here's what your area model can look like. I'm going to put spinner number 1 up on top, and I'm going to put spinner 2 over here on the side. It doesn't matter if you switch them. Spinner 1 has 3 different choices where spinner 2 has 2 of them, and then you can go ahead and fill in the probabilities right now and see what we come up with. Alright, so I made my area model and I multiplied all of the dimensions of each smaller rectangle together, and you can see their outcomes right here circled in green. And so what this is lending itself useful then is I got the 3 things that would form a word, it, at, and if, and I added those probabilities together, and that got 0.583 or 58.3%. And so the probability that we would win this game is 58.3% by adding up the associated probabilities from each of the spinners. So is this game fair? No, it's not. It's actually leaning in your favor, which is a good thing to do. And so can you be sure that you would want to play this? Yeah, I think that'd be a good thing to do. So this again was dealing with sample space and a probability area model. On the next slide, we're going to take some math notes on the difference between that and what we're going to introduce to you called a tree diagram. So this math notes on probability models is a great thing to get down. It says when all of the possible outcomes are equally likely, you can calculate the probability as follows. That sounds more complicated than it is, but the idea of 3 out of 4, meaning that you have a 3/4 possibility of getting something to happen, that's essentially what theoretical probability is discussing. A probability area model is exactly like what we did on the previous problem, something like this right here, okay? And it's practical if there are 2 situations, okay? However, what's going to happen is if there are more than 2 probabilistic, that's a big word, situations, and the events can be independent or not, we can use something down here called a tree diagram. And this right here is an example of a tree diagram of the exact same problem, just with the probabilities listed a little bit differently. In this model, as it says, the ends of the branches indicate the outcomes of each situation. So for example, if you started right here, we could spin and we could get an I, or we could get an A, or we could get a U. And then from that first one, if we got an I, remember, the second spinner we could have gotten an F or a T. And so the probability model starts by just branching out like a tree does. Okay, it says, for example, in the tree diagram at the right, the first branching point represents spinner number 1. So this point right here represents spinner number 1. And then each of the associated vertices right here represents spinner number 2. The numbers on the far right of the table represent the probabilities of various outcomes. So for example, the probability of spinning a U and a T can be found at the end of the bold branch of the tree. So what they're really emphasizing is that in order to get your final answer of 1/8, that was multiplied by taking this branch probability times this branch probability, and 1/4 times 1/2 is 1/8, and that is the combination of I and T, and that's for it. Now if you wanted to do a different one, you could go getting an I and then getting an F. That would be multiplying 1/2 and 3/4 together, which gives us 3/8. And so this branching or this tree diagram is great when we have more than 2 possible outcomes for a situation. Now you can be fluid with either. I'm not saying you have to use one or the other, but I just wanted to introduce to you this different type of probability model. that's all the information that we're going to have for today. We're not going to expound upon that anymore. As we move forward with the rest of this unit, remember that we're going to have a test on this coming Thursday, April 30th. If you have any questions, by all means, please feel free to swing by my office hours. And then we will hopefully chat soon. Take care, stay safe, and stay healthy.